and it works, but they just did it separately.
Thank you. Okay, so one thing I want to point out is I can't cover everything that I saw students doing, but I'm going to look at a lot of the main ideas. First off, I saw some students very successfully recognizing, okay, so I have a 0, -1, and 1, and 0. So some people were starting at -3, and then -2. I'm going to leave a space because I'm going to come back to this in a second. And then 0, and then 1, and I'm going to stop at 2 for now. And so they made this table, right? Do not forget, f of x is x minus 1 times x plus 1. So for this -3, I would have to substitute it in. F of -3 would be -3 minus 1 times -3 plus 1, and I believe that comes out to be 8. What? That's -4 times -2 is a positive 8. Now I want to pause and I want to point this out. If I remember correctly, Jakeem, you actually, instead of doing f of x, you did one column for x plus 1 and one column for x minus 1. You can do that as well if you want to separate them and just multiply all three. But there is that value. So then when I do x times f of x, and some students were trying to make an extra column. I don't need an extra column because I just need x times f of x. That's it. -24. Now, don't forget with this -2, can I substitute that in for x as well? Yes, but I don't have to because here's an x value of -2. You see how that has a y value of 3? -2 comma 3. So what is f of x? -2 comma 3, so f of x is 3. That's all you would have to do if you have that point on the graph. Don't make it harder than that. Okay? Well, and note, again, 0, the y value is -1, be careful. But then that product is 0, and 0, and then 1. And I believe it's 2, 3 that gives us a 6. Now, I don't love this because it doesn't give me great points. It's worse. So -2, -6, I would have to estimate that it's roughly down here. Somewhere. -1, 0. 0, 0. 1, 0. And then 2, 6. And so I saw some students do this. Does that work? So, hold on. And I need y'all to pay attention to this. Does anyone know how many zeros this function would currently have?
Like 6, like 5, like 1.
There's actually going to be, and I know it's going to blow your mind a little bit. Right now, there's infinitely many. Because here's a 0, here's a 0, here's a 0, here's a 0. There's infinitely many little zeros along that x-axis. You can only have how many though? Or how many are you supposed to have? Only 3. So, Tyrese, I think you were mentioning this or saying this out loud a second ago, that it needs to go up into the positives. I want y'all to notice, are any of these zeros double roots? So it needs to go through the x-axis if it's not a double root. And so it's going to go into the positives and then back down and into the negatives and back up. And if you were one of the students who took the time to go by halves, you already knew that. Because you could have done -1.5 here, -0.5, 0.5, and 1.5. And I don't remember f of x for -1.5. Is that 1.75? No, 1.25. Does that look right for those of y'all who did it? Yes, Mr. Kenny. Thanks, guys. So I do remember this off the top of my head a little bit. And then, So that created some more points for us. I think it was 1.875. No, negative 1.875. A positive 0.375, negative 0.375, and a positive 1.875. So notice we get those points as well. Now, I will point this out, you don't have to have gone to that level of detail. Why are you looking at me like that? Well, so here's my thing. If you go by 0.5, will it give you more accuracy? Yes. Did you have to though?
Yes.
You don't have to. Because if you know that none of those roots are double roots, you know you've got to go through it, right? Which means you'd have to go into the positives and come back down through that 0, go into the negatives, and then go back up through that 0 and go into the positives. That would have been okay in just approximating where the max and the min were. That's okay with me. But I will point out that if you do the halves, you do see that extra level of detail. Okay? And Momar, you originally had that flat line here in the middle, right? And then how did you realize that you were wrong?
You went over it.
No, you realized it earlier. I was saying, you literally graphed. Did you not graph it?
Did.
I watched you graph it, and it showed because it showed a pink curve that looked like this. The reason why I say all this, I want you to notice you can graph this to help you notice if you're or figure out if you're doing things right or wrong. Now, 2 quick notes with that is this. Because Momar did remind me that you can do something that I haven't shown y'all yet. First off, it's x times f of x, right? And what was the expression or equation for f of x? X minus 1 times x plus 1. So you could have just gone straight to this. Enter. That looks like what we just had, right? See how it's going up and down through there? So Momar, though, took the time to actually do this, and this is a good thing to note. He graphed f of x. Oh, that's not f of x. I'm glad I could bring you such joy. All right, so there's f of x, right? We go with that? Now, if you graph that function, notice how it has x minus 1 times x plus 1 as f3 of x. So if I go to f4 of x, I can actually do x times f3 of x.
Oh wow.
So if you have graphed the first function, you can use that method of x times f of x or something like that to figure it out as well. But these graphing calculators are powerful to help you check yourself. Please note, on assessments, do you think I'm going to let you have a graphing calculator if it can tell you the answer right away? Not for the whole thing.
Well, I need to learn how to do this right here.
That's why we're doing some practice right now. We've got 3 more things to practice on. So, practice within your small groups. Check yourself on your calculators. Let's get to work. Yes, you're going to be, make sure you have A done correctly before you move on though. Pay attention to your scale. Check your graph versus what's on the calculator or what's right here. No, you're never allowed to use restroom ever again. Oh, joke.